In this video, we are again looking at two triangles, but this time we are not trying to prove just that they're congruent, but we're trying to prove that two angles are congruent. So as we can see in the problem here, we're trying to prove that angle A is congruent to angle D. Those are the angles at the tops of these two triangles. And these two triangles look like they're the same, but the angles look like they're the same, but how do we go about proving that they're the same? We can look at what we're given in the problem, and we're given that side AB is congruent to DE, so those are the ones marked in green on the outsides of the two triangles. We're also given that side AC is congruent to side DC, so those are the ones marked in, let's call it orange, an orangish color here on the insides of the two triangles. And then we're given that point C is the midpoint of BE, so that's the point on the bottom here of the line. So C basically is right in the middle of BE. And that's it. So we're not told that the triangles are congruent. We're not given any angles, but somehow we have to prove that two angles are congruent. So how do we do that? Well, it seems maybe like something we can't do, but we know that in congruent triangles, the corresponding parts are congruent. So we know that if these two triangles were congruent, and they look congruent, then two parts that correspond, so the parts at the same point on each one of them, are going to be congruent. So the first thing we have to do, and this is pretty common in geometric proofs, is prove the two triangles are congruent. And once we know that, then we can say that any two things that correspond, anything that is at this point in one and is at this point in the other, are going to be the same. So how do we go about proving that these two triangles are congruent? Well, we're given these two sides and no angles. So when we think about all our possible ways of proving that triangles are congruent, like the side angle side, the angle side, those aren't going to work here because we don't have any angles. So we need one that is based on sides. Fortunately, there is the side postulate. And all we need for that is three sides. Well, we're already given two, so we just need to find a third. But fortunately, we know that C is the midpoint of BE. So if C is the midpoint of BE, that means that BC is congruent to CE. And there it is. We've got three sides that are congruent. So in our proof, if we can get to this point, and then we can say that triangle ABC is congruent to triangle DEC, then the next thing we can say is that the corresponding parts of congruent triangles are congruent, so A will be congruent to D. So let's show that in a proof. So we've got our statement and our reason column, and we got a bunch of boxes, and it doesn't matter how many boxes we put. We're just going to kind of go until we run out, and if we need more, we'll add more. And then we're going to start putting statements down. So our first statement is C is the midpoint of BE, and it doesn't really matter which one you do first, but we're going to start with this one. Reason for that is given, so that's given to us in the problem, therefore it must be true. Then we're going to say that BC is congruent to CE, and again we just talked about how we know that because that is the definition of a midpoint, so that's the reason that we give. So now we've presented that evidence for our first side. Then we're going to say that AB is congruent to DE, that is given in the problem. And we're going to say AC is congruent to DC, and that also is given in the problem. And now here we have our side. So that was what we were trying to get. We're trying to present those pieces of evidence in order to reach our conclusion that triangle ABC is congruent to triangle DEC. And it's important here to note that the letters correspond. So we said that AC is congruent to DC, and here A and C and D and C are in the same points in the way we label these triangles. And then the reason for that is the side postulate. So if that's all we're trying to do, we'd be done. But we need to do one more thing, which is to say that angle A is congruent to angle D. And that's where we use this really useful reason of CP-CTC. So I've been saying that a lot. Corresponding parts of congruent triangles are congruent. So that means that we could say angle A is congruent to angle D. We could also say that angle B, if we wanted to, is congruent to angle E. And note that these are the ones that come at the same point in the way we're describing these triangles. And we could also say that angle ACB is congruent to angle DCE if we wanted to. And again, those also are at the same point in the triangle. But proving that angle A is congruent to angle D is what we're trying to say. So we're done. And again, CPCTC, it's a bit of a mouthful, but it's really useful. As long as you've proven that two triangles are congruent, you can say a whole lot of things about those triangles.